Hi everyone. So today we'll be starting with a chapter of dentin, and the first topic that we'll cover in this chapter is physical and chemical properties of dentin. So this topic itself comes in as a short note, and this slide is a summary of whatever is given in your organs textbook regarding the physical and chemical properties of dentin. So first talking about the physical properties, it is viscoelastic and can get slightly deformed. So when you imagine dentin, it is a very hard structure, right? But it can undergo slight deformation and then rebounds. Okay. Then talking about the hardness, so it is harder than bone, but it is softer or less hard than the enamel. Okay, so the hardness lies between bone and enamel. Now it is harder in the central part than near the pulp or its periphery. So if you have your teeth over here, okay, and then you have this entire portion is dentin, right? So this is, let's say this is the pulp and then this is all is dentin. So it is harder in the central portion. I'll take another color. It is harder in the central portion than all the yellow parts, okay? So it is harder than in the central part than the periphery. Now it is more radiolucent due to lower mineral content. So radiolucent means that it allows the X-rays to pass through it. So it will appear slightly more whitish than the enamel in an X-ray. Okay. So this is about the physical properties. Now talking about the chemical properties. So the dentin has two components, organic and inorganic. So it has 35% organic components and 65% inorganic components. Talking about the organic components, so it has collagen fibrils embedded in the ground substance of mucopolysaccharides. Okay, so anything, it will have a ground substance most probably. So grounds, we have this ground substance. It is basically a matrix. Okay, and then you have collagen fibers in here, right? In this ground substance. Now these are type 1 collagen fibers. Okay, mostly type 1, and then uh, it is very similar to the organic matrix of dent and bone. Okay, so the dentin has a matrix similar to bone, but a protein, that is sialoprotein, it is only present in dentin. Sialoprotein and phosphoprotein, these are only present in the dentin. They are not present in bone. Okay, so everything else might be a bit similar, but these proteins are only present in dentin. Now talking about the inorganic components. So we all know that the enamel was made up of hydroxyapatite crystals, so is the dentin. Okay, so this is the main inorganic component, and one of these crystals is made up of thousands of unit cells. Okay, so this is the formula of hydroxyapatite crystal. It is important to remember that, okay? And these crystals are plate shaped and are much smaller than crystals of the enamel. So remember, enamel is also made up of hydroxyapatite crystals, but the hydroxyapatite crystals of enamel are way larger than the ones of the dentin. Okay, so enamel would be like if this size, then dentin would be slightly, not slightly, actually a lot smaller. Okay, and then the hydroxyapatite crystals are poor in calcium but rich in carbon as compared to enamel. Okay, they also contain phosphate, carbonates, and sulfates. So this is about the inorganic component. It is mainly hydroxyapatite crystals. Now moving on to the structure of dentin. Okay, what does the dentin look like? So we all know that this is our enamel. This outer portion of the tooth, this is enamel. And if I cut the tooth, so I take a tooth and I cut it like from here. I take a cross section. So this portion is your dentin. Now, if I zoom in, you can see pulp over here. This is your pulp. And talking about your dentin, what it actually contains. So you have these odontoblastic process. I will use a different color. So you have these odontoblasts. These are the dentin forming cells, okay? And they lie in the pulp. The cell bodies lies inside the pulp, and these processes, these extensions, they are in the dentin. So if I make a representation of this over here. You can see these are my odontoblastic processes. Okay, this entire thing is the pulp chamber, and these are my odontoblastic processes. Now surrounding this, you can see over here, this is a tubule. Okay, this is a tubule. This is called the dentinal tubule. Uh, I did not, yeah, I did label this. Okay, so this entire thing is the dentinal tubule over here. Over here, you can see this is the dentinal tubule. So your dentin is made up of your dentinal tubules and uh, a substance in between these tubules. This is called the intertubular dentin. So this has many components. If I redraw it for you, a rough diagram. So I have this. This is my pulp, okay, and I have these odontoblasts over here. I have these processes coming out of these odontoblasts. Now surrounding these processes, I have these thing like a tubule, okay. So these are called dentinal tubules. They form the dentin. Now, outside these dentinal tubules, I have that is also dentin, but it is slightly different in composition. Okay, so between these dentinal tubules, I have something called intertubular dentin. So this is intertubular dentin. You can see over here as well. And inside, if I zoom in into these dentinal tubules, they are surrounded. The inside it has something called the peritubular dentin. Okay, so the dentin that surrounds the immediate dentinal tubules, that it is peritubular dentin. You can see over here. So this dentin inside the surface of the dentinal tubules. This is the peritubular dentin, and inside that you have your odontoblastic process. So this is the entire structure of dentin. We'll talk about this later on, but over here you have a fluid that is called dentinal fluid. Okay, so this space would be filled with a fluid called dentinal fluid. This is the structure of dentin. Now moving ahead with we'll have to talk about all of these, this peritubular dentin, intertubular dentin, odontoblastic process, dentinal tubule. Will talk about all of this in detail. Okay, these are all like short questions. So we'll dive into that. Now starting with the dentinal tubules. So what are they? They are sigmoid shaped. Okay, so the shape is S-like. You can see over here. The shape of the dentinal tubules, they will go something like this, okay, throughout the length. So they're S-shaped and they show a primary curvature, okay. The curve starts at right angle from the pulp and is doubly curved. So your dentinal tubules, if this is the pulp, right, if this is the pulp, so they will start at right angle, okay. So they'll start over here like this. And then the first curve is towards the root apex. So the first curve will go down and then it'll go up, right? So it will continue over here. So this is the curvature of the primary curvature of the dentinal tubules. Okay. Now this point is talking about the first curvature, right? Now terminal branches. So as the tubules end, they have like some branching. Okay. So that is called terminal branches. The branches of the dentinal tubules near the terminal. So terminal means where they end. Okay. So the enamel starts here, right? So these branches, they are more profuse in the root dentin than the coronal dentin. So the root dentin will have maybe like 6 to 7 branches, and the coronal dentin will have maybe 2 or 3 branches. Okay, the number of tubules per unit area on the pulpal surface, two. So the ratio of the number of tubules per unit area on the pulpal surface to the outer surface is 4 to 1. So if I take um let's say 1 centimeter cube of area over here and 1 centimeter cube of over here, area of over here. So on the pulpal surface, I will find 4 dentinal tubules, right? So this should have 4 dentinal tubules, but on the outer surface, I'll have only one. And the thickness of the dentinal tubules near the pulp is 3 to 4 micrometers, okay, and then the outer end, that is only 1 micrometer, so it reduces in thickness as well. So on the inner side of the pulp we have more tubules, more concentrated tubules, and thicker tubules as well. Okay, ratio of dentin near the pulp to the outer surface is 1 to 5. Okay, so in general, just the ratio, the quantity of dentin near the pulp is 1, on the outer surface it is 5. Okay, right. So this is all about dentinal tubules. Now moving ahead to the next topic, that is okay, we have something left in the dentinal tubules. We didn't talk about the secondary curvatures. Okay, so I told you what the dentinal tubules are shaped like this. Okay, but if you zoom in into these dentinal tubules, you will find these secondary curvatures. Okay, so this is like these lines are not actually going straight like this, they are kind like this. Okay, like this. So they have like a curve going inside them of their own. That is called a secondary curvature. Okay, so these are present throughout the tubules. Lateral branches or canaculi, they are also present throughout the dentine. They are less than 1 micrometer in length and they originate at every 1 to 2 micrometers along the length of the dentinal tubules. So you can see these slight branches on the dentinal tubules. These are called canaculi or microtubules. Okay, they are present throughout the dentinal tubules and they are less than 1 micrometer in length and they are present after every 1 to 2 micrometers. Okay, now the few dentinal tubules which cross the dentinal enamel junction and extend into the enamel are called enamel spindles. So I have the tooth over here and this is my pulp and this is where the enamel is ending. Now I have these dentinal tubules, let's say, and they cross the dentinal enamel junction. Okay, these ones they cross the dentinal enamel junction. So this structure over here, it will be called enamel spindle. Okay, you can see in this diagram these dentinal tubules which crossed the dentinal enamel junction, they are called enamel spindles. Okay, now moving ahead to the next topic, that is odontoblastic processes. So we talked about the first part, that was the dentinal tubules and their shape and how they run. Now inside this dentinal tubules, we had our odontoblastic processes, right? So this was the odontoblast and the extension of the odontoblast. So this is called the odontoblastic process. Now, what are they? They are cytoplasmic extensions of the odontoblast. Odontoblasts are the cells which form the dentine. Okay, and they are composed of microtubules. Now the diameter is largest near the pulp, so over here they are the thickest and they taper to 1 micrometer further into the dentine. So over here they are around, the thickness is around 3 to 4 micrometers and over here it is about 1 micrometer. Now the cell bodies are 40 micrometers in length and 7 micrometer in diameter. So if you talk about the cell body, so this would the shape would actually be like this and this would be 40 micrometers in length and 7 micrometers in diameter. Now the lifespan, it is same as the age of the tooth, because once an odontoblast is formed, it cannot be reformed or it cannot undergo further division. Okay, so the lifespan of odontoblast is same as the age of the tooth. Okay, some odontoblast processes transfers the thickness of the dentine. Okay, so this what this point is saying is that some odontoblastic processes are long and some are short. So if I draw a picture over here, so if I have two tubules, let's say one is going like this and one is going like this. Okay, so some processes might end over here and some might cross this entire thing and enter the dentino-enamel junction. So this one, the shorter one, it is mainly a characteristic of tubules that are narrow or obliterated by mineral deposits. So maybe some minerals got deposited over here and that's why this odontoblastic extension is short in here. Okay, and this is a diagrammatic representation of what the structure of the dentinal tubule. Okay, not a dentinal tubule and everything inside it. Okay, so this whole thing is a dentinal tubule. And if you look over here, so this is your odontoblast, obviously, right? This is your odontoblast. This is the extension. So this is the odontoblastic process. If I highlight over here the odontoblastic process, then outside the odontoblast, you have this entire thing is your dentinal tubule, right? Now inside this you have this dentinal fluid. Okay, this fluid surrounds the odontoblastic process, and surrounding the tubule or forming the border of this tubule is the peritubular dentin. And inside of the peritubular dentin, it is covered by an organic membrane called the lamina limitans. Okay, we'll talk all about this in later in this lecture right now. Okay, and the dentin between two dentinal tubules is the intertubular dentin. Okay, so talking about the next topic, that is the peritubular dentin. So this dentin present over here, um, this dentin that forms the boundary of the dentinal tubule. Okay, so this is the peritubular dentin. We'll talk about this right now. So this the dentin that immediately surrounds the dentinal tubule is called the peritubular dentin. It can also be called the intratubular dentin because it is present inside the tubules. Okay. Now it forms the walls of the tubules in all the region except the dentin near the pulp, which should be pulp, right? It is more mineralized than the intertubular dentin. So remember, this is the intertubular dentin. The dentin that is present between two tubules, right? This is the intertubular dentin. So this peritubular dentin, it is more mineralized than this one. Okay. Uh, Now about it is about 9% more mineralized. Okay. The outer dentin and its thickness is approximately 7.5 micrometer, while the inner dentin is almost half. Okay, so in the outer, if this is your tooth, so the thickness of the peritubular dentin over here, and the outer ones, it would be around 0.5 micrometers. So here it would be around 0.5 micrometers. Sorry, 0.75 micrometers. It would be thicker in the outer areas. I'll just redraw this, okay? So this is your tooth, this is your pulp, okay? Here the enamel ends, and this is my dentinal tubule, okay? So my peritubular dentin, it is thicker in the outer region. So over here, maybe I have this much portion filled with peritubular dentin, but in the inner area, it is about half of the uh, area that it covers in the outermost region. Okay, so this is what is meant by this point. Okay. So over here, the thickness is 0.75 micrometers, but inside it is 0.4 micrometers approximately. It grows to constrict the dentinal tubules at 1 micrometer near the dentino-enamel junction. So it is saying that because at the periphery, the peritubular dentin gets so thick, it constricts your dentinal tubule uh, at around, so the thickness of the dentinal tubule will be 1 micrometer over here. Okay, only 1 micrometer of space will remain over here. The lamina limitans, it is an inner organic membrane, inner organic lining of the calcified tubule. It is a thin organic membrane and high in glycosaminoglycans, and it is similar to lining of lacunae in cartilage and bone. So it is basically an organic membrane that surrounds this uh, peritubular dentin. Okay, so this is a membrane surrounding this peritubular dentin. Now, periodontoblastic space. It is the space that is present between odontoblastic process and peritubular dentin. The space contains dentinal fluid. So if I go back to this diagram, all this blue space, right? All this blue space, it is peritubular space. Okay, and this contains the dentinal fluid. Now the fluid has high potassium and low sodium content, and the flow is outwards from the pulp. So the liquid flows in this direction. Okay. So coming to the next topic, that is the intertubular dentin. Okay. So what is intertubular dentin? If I go back, it is the dentin that is located between two dentinal tubules. Okay. So these are my dentinal tubules. I'll actually just redraw the entire diagram. So this is my tooth. okay, my pulp, and if this entire thing is my dentin, so I have these two dentinal tubules, right? And the dentin that is present in between them, right? This is the intertubular dentin. Okay, so if I take a cross section from over here, let's just say I cut this tooth surface from over here, right? What you will see will be something like this. Okay, you will see this. So what this shows you, if I zoom in, you can see these are your dentinal tubules. Okay, so your dentinal tubule outside, the inside is made up of odontoblastic process. Okay, then so you have this just use a normal thing. So you have the inside is your odontoblastic process. Now surrounding that you have peritubular dentin. Okay, so surrounding the odontoblastic process, actually in true sense you would have periodontoblastic space, right? So this is the space surrounding the odontoblastic process, your periodontoblastic space, and surrounding that you have your peritubular dentin. Now this is your dentinal tubule, okay? And you have tons of dentinal tubules uh, like this. Mm, I just copied the whole thing. So let's just say that you have many dentinal tubules like this, right? And the space in between them, it is filled with something called the intertubular dentin. So it is located between the dentinal tubules, okay? It forms the main body, the bulk of the dentin, okay? It is highly mineralized, okay, but its matrix is retained upon decalcification. So what happens is when something is highly mineralized, okay, and I decalcify it, it means that it lost all its minerals, right? So when it was highly mineralized and it loses all of its minerals, then nothing should stay, okay, nothing will be retained. But in this case, it is highly mineralized, okay, but still, upon decalcification, some of its matrix will remain. This does not happen in the peritubular dentin. Okay, so the peritubular dentin is also highly calcified, but it loses all of its matrix upon decalcification. Intertubular dentin does not. Okay, so you will be able to see the intertubular dentin in a ground section. Okay, about half of its original volume is organic matrix. Okay, it mainly consists of collagen fibers randomly oriented around the dentinal tubules. Okay, so it is saying, I told you, for anything you will have an organic matrix if you talk about the microscopic structure, and then it has collagen fibers lying randomly in this ground substance. Okay, so this is the microstructure. Now the collagen fibers show banding at 6 to 4 micrometers, and hydroxyapatite crystals are formed along the fibers with their long axes parallel to the collagen. So the collagen over here would be, it will show some banding after 64 micrometers of distance, okay? And the hydroxyapatite crystals, these are formed parallel to the collagen fibers. Okay, so they lie along the collagen fibers and they are oriented parallel to the collagen. Okay, so this is about the structure of the intertubular dentin. Now moving to the next structure, it is incremental lines of von Ebner. So what are these lines? If you look at a ground section, your dentinal tubules will have these lines. Okay, these lines you can see. So these are not these are your dentinal tubules, okay? And these horizontal lines you see, I'll use a different color. These horizontal lines along the dentin, these are incremental lines of von Ebner. Now what are they? These are fine lines running at right angles to the dentinal tubules. Over here you can see these are at 90 degrees, okay? The dentinal tubule is this, and this is your incremental line. They are at 90 degrees at right angles, okay? They represent daily rhythmic deposition of the dentinal matrix, okay? So when the dentin is being formed, okay? So maybe it the dentin was formed this much in a day, okay, and then the formation slowed down. So when the formation slowed down, a line will be formed, okay. Then the formation started again, and all of this was uniform deposition of dentin, and maybe then it slowed down for a few days. So this gap will represent a period. So the dentin started like forming, and then the formation slowed down or stopped. Then again it started forming, and the deposition slowed down. So maybe after every 20 days, we have a slowdown and then we get a line. So each of these lines, it is believed that a 20 micrometer gap represents a 5-day interval in the dentine formation. Okay. So if this gap is 20 micrometer, I can say that this much formation of dentine took 5 days. Okay. Now, so approximately 4 micrometers of dentine is formed daily, right? Then the lines are further apart in the coronal dentin, 8 micrometers, and they are closer together in the radicular dentin. So if you see over here, this is a diagram from the Owen. So over here you can see the gap between two lines is bigger. Okay, so this is around 8 micrometers, but if you go down here, the gap between two lines is smaller. It is around 3.5 micrometers. So the dentine was formed faster over here compared to the coronal area. Okay, now moving to the modification, not modification, but special type of incremental lines. Okay, so there are two types. First is contour line of Owen. Okay, this is nothing. This is just like an accentuated, so kind of a highlighted incremental line. If you look in this diagram as well, you'll be able to see over here. You can see this extra dark line. Okay, so this is your uh, line of contour line of Owen. Okay, now, why it happens? It is due to disturbance at the matrix and mineralization process. Okay, so when any formation deform formation def not irregularity happens, then you can see these lines. Okay, these are hypocalcified structures, so they are not highly mineralized. Okay, uh, one example of this accentuated line is neonatal line. Okay, so neonatal line, when it is formed, I told you when there is any disturbance in the formation of the matrix, okay, then you see this line. So this line is seen between your postnatal and prenatal dentin. Okay, so some teeth you would know that the development starts uh, when the baby is in the gestation period. Okay, so during pregnancy the formation of the dentin start, but after the birth the environment changes. Okay, when the baby is born the environment changes, so the quality of the dentin formed is different. So over here you can see we have prenatal dentin, we have this neonatal line. So even if I go back, right, you will see the slight demarcation. This is the neonatal line, and then this is the postnatal dentin. So you can see a difference in the color. Okay, so this line, it demarcates the difference in the matrix composition of the prenatal and the postnatal dentin. Okay, it is seen in the first permanent molars and the deciduous tooth because they start forming while the baby is uh, in the uterus. Okay, so when the dentin is formed partially before birth and partially after birth, okay, in these two types of teeth. Then this reflects the abrupt change in environment. So I told you these lines are seen when you see any irregularity in the matrix formation or the mineralization. So that would happen because of an abrupt change in environment, and that is before birth and the after birth. Okay. Generally, the dentin formed before birth is of higher quality because more of the nutrients are available to the baby. Okay. After birth, the nutrients may or may not be available to the baby. If you look at this diagram, this photograph, then you can clearly appreciate the lines of Owen over here. Okay, so these are the accentuated lines. This is different. This is not the neonatal line. Okay, but over here you can see another type of lines of Owen clearly. These are your normal lines, normal incremental lines, and then you can see the sorry, these are your normal incremental lines, and then over here you can see the few accentuated, like these ones are slightly more highlighted. These are your line of Owen. Okay. Now moving ahead to the next topic, that is the Tome's granular layer. Okay. So this is not actually a structure. This is something that is seen because we decalcify a tissue. Okay. So if this is my teeth, I just draw. Right, this is my crown, let's say, and this is my root, and I have dentinal tubes. So this is my pulp and everything. Okay, and I have dentinal tubules that are passing through this. Okay, and this is my cementum. Let's say outside over here I have cementum. Now I took a cross section. Okay, so I cut this tooth like here. So these dentinal tubules which had some branching over here, okay, they would get cut. These branches they would get cut, and they would maybe they were coming out at a right angle. Okay, so these tubules that were looping and coming out at right angles, okay, they will remain as a dot because they were maybe like this, but I cut it from over here, right, for a cross section. So I cut this thing from here, and you would see a dot. So there are many dots like that present at the cemento enamel junction. Sorry, cement entangle junction. Okay, so this is my tooth, and you would see this granular layer because of the looping of dentinal tubules. So I would see many such dots. So maybe they were coming out like this, but they got cut because of the formation of the cross section. So what are they? It is a granular zone adjacent to the cementum over here, visible in ground section of root dentin when visualized under transmitted light. Okay, so it can only be seen in transmitted light. Now it is caused due to cohesing and looping of the terminal portion of the dentinal tubules. So a dentinal tubule, it was going like this towards the end. Maybe it had some looping. It was going up and this, and then this portion, the going up portion got cut, and it remained as a dot in there. Okay. So this zone increases slightly in amount from cemento enamel junction to the root apex. So if you look at this picture, the area is getting thicker, okay, and darker. Over here there are lesser granules, but as you go down there are more granules. So as you go towards the root, the zone will increase slightly in amount. Okay, uh, there's no as such significance, but if you have to draw a diagram, you would draw it something like this. So these are your dentinal tubules, and this is your granular layer, and then you have your cement. Okay? So it is present between the cementum and the dentin. So this is it for this lecture. Okay, we'll continue the chapter in the next lectures. I hope you like it. Thank you.